Okay, so in this video, we are going to talk about definite integrals, which is like uh, the continuation from the previous video about integrals. I have to clarify something from the previous video, and it's that I forgot to add the constant to the final integral of the final example of that video. So please excuse me for that. That's super important, and yet I forgot to write it. So let's continue with this video. So what are definite integrals? Um, Basically, are exact calculations of areas between 2 points of x. What do I mean by that? So if this function, which is a quadratic function, looks more or less like this, um, what this integral is telling you is the area between 2 and 3 over the x-axis. 2 and 3. Sorry, here should be 1. So it's this area. How are we going to calculate it? Okay, first of all, I need to clarify that for definite integrals, now it's not necessary to write the constant, because we are asking for specific values of this specific function. We are not returning from to an original function after being differentiated. No, this is just the calculation of the area between 2 and 3. So in this specific case, the constant is not needed. So how do we do that? First of all, we need to integrate this, okay? And we are going to manage the notation a little bit differently, okay? So first, let's find the antiderivative, which is like basically the integral for this term. So it's 3x squared plus 1 over 2 plus 1. But this is 3 and this is 3, so let's rewrite it as such. And these two things can be cancelled, so basically the antiderivative is just x cubed. Okay, but look at the notation here. Since we want it between 2 and 3, we are going to use this square bracket with 2 and with 3, because we already integrated, and we are going to evaluate this function, this new expression, in 2 and in 3. And we are going to subtract them together. First this one, and second this one. So it's really important to write each one between brackets, because since we are going to be doing a subtraction between those two things, this minus could affect what is here, and we should be aware of that. So let's evaluate it in 3. It's 3 to the power 3 minus 2 to the power 3. That will be 3 to the power 3 is 27, and 2 to the power 3 is 8. That will give us 19. The value of the area of this curve, let me try to draw it again, between 2 and between 3, this area is 19 square units. Okay, here we didn't need the plus c, but it is necessary when we are dealing with indefinite integrals. So please again excuse my mistake from the previous video. Okay, let's do it with this one, and we will wrap up this video. Be careful. Okay, so first let's find the antiderivative. Sorry, yes, antiderivative minus 4x cubed plus 1 over 4, because this is 4, right? Okay, but this can be cancelled with this one, so it's just negative x to the power 4. Negative x to the power 4. And what happens here? What happens with these two? How do we integrate it? So it's really similar to what happened with the derivatives, but the opposite way. Remember that when you had a constant and you differentiate it, just the coefficient remains and the x disappears. So we are basically doing the opposite. Why does that happen? Because here with the 2, it's an x to the power 0. So let me show you what will happen. We add 2x 0 plus 1, 0 plus 1. This is just 1, so let me do it. X to the power 1 over 1. So 2x to the power 1 over 1. But this one is not necessary, and this one is not necessary, so it's just 2x. 2x. And remember, since we are dealing with definite integrals, we are going to use this square bracket to make sure to know that it's between 1 and 5. And then we assess, we evaluate this function in 5 and subtract it with this function in 1. So negative 5 over 4 plus 2 times 5 minus negative 1 over 4, sorry, to the power 4, 2 times 1. Okay, negative 5 over 4. Let's calculate that. Five to the power 4. Okay, negative 5 to the power 4. 5 times 5 times 5 times 5. Okay, it's 625, but be careful. Okay, because the base was negative. I wrote it wrong. So it's multiplied by itself 4 times. So it's basically negative times negative times negative times negative. So this 2 is positive, this 2 is positive, and positive times positive is positive. So yeah, it's positive. Plus 10. Minus, again, it will be positive 1. 1 to the power 4 is 1 plus 2. Let me erase all of this. And this is 635 minus 3, which will be 632. That's the value of the area of this function between below that function between 1 and 5. Okay, so basically that's how you deal with definite integrals.